Welcome to my video on looking at the area of circles. Now, as we've mentioned in previous videos, when we're looking at area, the unit is always squared. So millimeters squared, centimeters squared, meters squared, kilometers squared. And that is exactly the same when we're looking at the area of circles. Now, generally, when we're looking at shapes and area, we're looking at dimensions such as length and height, but things are a bit different when it comes to a circle. With circles, we have our diameter, which is the distance cut straight across the circle. We have the radius, which is half of the diameter. It's from the origin in the center of the circle to the side of the circle. And then instead of the perimeter, we call the outside edge of our circle the circumference. Now, when we work with circles, we work with this mathematical constant called pi. Now, pi is this value, and we use the value as 3.14. On your calculators, you will find the pi symbol, and you can just press that if you're using pi. Now, in a previous unit, we learned that the perimeter of a circle is actually called the circumference. So if you imagine me here, I'm running around the circumference of the circle, the perimeter of the circle, the outside edge of it, known as the circumference. We learned in a previous video that to find out the distance of the circumference of the circle, we multiplied the diameter by pi. Okay, so let's think about this. The link between a circle's circumference and diameter and pi. Okay, if we divide the circumference of the circle by its diameter, that will give us the value of pi. So that is the relationship to it. If we multiply the diameter by pi, we get the circumference. Tricky relationship. Okay, so thinking about area and our circles. We've learned in a previous video how we do these conversions. Okay, so if we've got meters squared and we want to get to kilometers squared, we have to divide our value by 1,000 squared. If we had meters squared and we want to get to centimeters squared, we have to multiply our value by 100 squared. So we use, depending on which way we want to travel, we either divide if we're increasing in size, or we multiply if we're decreasing in size. Okay, so let's think about our circle. We know that this is our circumference around the outside of our circle. Now if we cut our circle into even segments and then align them like this, hang on, we've got a parallelogram here. And we know that to find the area of the parallelogram, we do length times width. But we're not going to do that every time we get a circle, are we? There must be another way. Now, let's think this through a bit further. The distance of one of these segments is actually the radius, the distance from the centre of the circle out. So the distance along here could be termed as pi r. Why would that be? Now, that would be if we count all of the segments in half a circle. So we've got 1, 2, 3, 4, 5, 6, 7, 8 in this circle. Okay, and we count along here 1, 2, 3, 4, 5, 6, 7, 8. So that's the same. Alrighty, so this is becoming clearer. So if we multiply to find our area, to find out the area of all of these segments added together, if we multiply r by pi r, that would give us pi r squared. So our area is pi r squared. That's how we find the area of a circle, because we want to find the area of all of these segments put together. And we know that for an area of a parallelogram, we multiply length times width. So now we're multiplying our radius, which is that distance from the centre out, by pi r. What does that mean here? Let's have a look at it in this sense. Our area r squared here. So we want that radius, that square as its area would be r squared, because it's r times r. And then because we're talking a circle, we do pi times r squared will give us that area. Okay, now we've said that the area of a circle is area equals pi r squared. Cool. However, sometimes we have to rearrange that, because sometimes we're given an area and we might be given our radius, okay, and we need to work out pi. Or we're given our radius, we're given our area and we're given pi, so we might have to find out our radius. So we need to know how to rearrange our formulas. Here we're looking for whatever our radius is. In the case of the middle one, generally we know what pi is because we know that value, but you may want to double check your answer to make sure you get it correct. Here we would be looking for our radius, so we would be finding the square root of the area divided by pi. So it's just rearranging your formula depending on what you're looking for. Now, if you want to find the formula of a semicircle, we're still looking at pi r squared, but a semicircle is half of a circle, so we're going half pi r squared. Okay, again we've got our half pi here because we're looking at half of our circle and our half pi there. If we're looking at a quadrant, which is a quarter of a circle, now we've got our quarter pi because it's a quarter of the circle. And that's the end of looking at area in circles.